Today, you have notes on the greenhouse effect. Your essential question is, why is the greenhouse effect important? And as you go through this, if you need to pause the video in order to write, you should be doing that. I will be checking notes tomorrow. So the greenhouse effect. Gases in our atmosphere, they help keep the temperatures in a range suitable for us to live and for other animals, creatures. Most of our greenhouse gases are found in the troposphere, and what those gases do is they absorb infrared radiation from the sun. So here's just a picture going through the greenhouse effect. And then basically with greenhouse gases, is because of the shape of the molecule, they'll reflect the heat back towards Earth, which then increases the temperature of the surface, water, etc. With an enhanced greenhouse effect, we have a natural balance every single day between carbon dioxide production and oxygen production. When the greenhouse effect is enhanced, there's too much carbon dioxide being added to the system. So this contributes to too much carbon in the atmosphere, and then we got acidification happening, rising surface temperatures, and more. So acidification can be through acid rain or even ocean acidification, which will affect coral reefs. So greenhouse gases, what makes something a greenhouse gas? So we'll have more than one type of element. For example, water, you have hydrogen and oxygen. It would contain 3 or more total atoms. So water, for example, H2O, has more than 3 atoms because we have 2 hydrogens and 1 oxygen. Where if we have just nitrogen, we have 1 element. We don't have more than 3 total atoms. A greenhouse gas also needs to have a symmetrical shape, which, for example, our nitrogen here, if I cut it vertically and horizontally, it's going to be symmetrical, where if I try to do that with my water molecule, it is not going to be symmetrical. Greenhouse gases, they trap heat because the infrared radiation then increases vibrations between bonds of these not symmetrical molecules, which then allows them to reflect heat better, and we get a temperature rise. So on this slide, I have 3 different greenhouse gases. So we have H2O. The shape of water is bent, so the molecular geometry is what it's called. So it has a bent shape. If I was going to cut this in half, it's not going to be symmetrical both ways. It's a greenhouse gas because we have 3 total atoms and 2 different elements. Carbon dioxide is linear. And when you look at carbon dioxide, or CO2, if I was to cut this in half horizontally and vertically, it looks pretty symmetrical. Carbon dioxide's a little different because our bonds can stretch and compress a lot like a spring, which then makes it asymmetrical and makes it a greenhouse gas. It also has 3 total atoms, 2 different elements. Then we have methane, which is CH4. Its shape is tetrahedral. We have 5 total atoms. We have 2 different elements, and that makes it a greenhouse gas. Also, if I was going to try to figure out symmetry of it, it's not symmetrical all the time. Common greenhouse gases. So we have carbon dioxide. And the sources of this are burning fossil fuels, decay. It'd be waste product of respiration. We have nitrous oxide, which is from fertilizers and chemical factories. Methane comes from a lot of cattle, livestock farming, or agriculture, as well as landfills. And then we have water vapor, which is just naturally from evaporation. There's a video in the slideshow, so if that's something you want to go watch, you are welcome to do that for the greenhouse effect. And then lastly, we have how do we reduce greenhouse gases, which is get a home energy audit, looking at renewable energy, You could plant a native garden, so looking at native plants to the state of Minnesota, carpooling or using public transportation, raising, lowering your thermostats, recycling, and then making sure you're using energy efficient light bulbs, appliances, windows, and just being conscious of the gases and what we're putting out into the air and our environment.